In lesson 2.3, we're going to talk about something called finding the nth term. And so when you're finding the nth term, this is kind of a way that we use deductive reasoning. So let's say that we're trying to find the next term in the series 3, 7, 11, and 11, 15, and 19. A good way to do it would be to find a pattern. If we looked at the differences between the numbers, we see that the difference is 4, which means when we add 4, we get the next consecutive number. So after 19, of course, 19 plus 4, that would be 23. Now this method's fine unless you want to find a number in the sequence a long way off, kind of like maybe the 300th term. In that case, you want to come up with a rule that gives you that nth term. Sometimes it's called a function rule. And we're going to talk about how to do that in this next slide that you'll see coming up in slide number 2. So in this first slide, I just want to show you how the pattern works. So for example, first of all, the n thing is talking about the term number. So for example, this 1 is saying it's the first term. And then down below in the chart, this number is called the actual term itself. So as I look at this chart, this very first chart is saying the first term is -4, the second term is -3, the third term is -2. And if you notice the pattern going on, it looks like that every single time I'm going up by 1, so the next one would be -1, then I'd go to 0, and then 1, and then 2, and then 3. In the second one, we notice that when I do this, my first term is 1, my second term is 5, my third term is 9, my fourth term, if I notice the pattern, it means I'm going up by 4 each time, so then I would have 13, I go up by 4, I get 17, I go up by 4, I get 21, and then I get 25, and then I get 29. Why? Because my difference is 4, and I'm going up by 4 each time. And so these tables are all about finding out what your difference is and then changing the term by that amount. In the very last chart here, going from 3 to 1, I notice that I'm subtracting 2. Going from 1 to -1, I'm subtracting 2. So I see that my pattern is subtracting off 2 from the previous term. So -1 minus 2 is -3, -3 minus 2 is -5, -5 minus 2 is -7, so on and so forth throughout the chart. So this is one thing that you can do. Once you have your pattern, you can fill out a chart. Again, this is really convenient as long as the numbers that you're working with are relatively small and the chart goes in order. Sometimes that's not the case. So let's see what happens when that's not the case. In this next slide, we know that in the previous one, the rule was given and we can complete the sequence and tell what the difference was. Now we're going to come up with the rule. So in the previous slide, did you notice that the difference was the number in front of the n? So we didn't really talk about that, so let's talk about that. So here's what I notice. Every single time in my first chart on this picture, I knew that the rule in chart number 1 was every single time when I was changing numbers, I was adding 1. So to go from 0 to 1 was adding 1, 1 to 2 was adding 1, going from 2 to 3 was adding 1. Whatever you see there for the difference is the number that you put in front of n. So I go 1, n. What does that mean? That means that if I look at any number in the chart, let's say for example, I'm looking at the 7th term. So I look at the 7th term and I see that the number is 2. That means if I were to take that 7 and try to plug it into the n, so this 7, if I shove it into the n, I should see the number 2. Oh, darn it. 1 times 7 is not 2. Rats. I'm off by 5. Wow. Wait a minute. What if I were to shove in the 8 in for the n? 1 times 8 is 8. but I see a 3 in the chart. Oh no, I'm off by 5 again. That means that in order to make the rule, I have to subtract off 5 to make it work. And what you see is the rule that's been generated by the pattern that you found. So this is the rule that will find any term in your pattern box by plugging in which term you want. Notice that that rule was right here, n minus 5. So for example, in this very first chart box, if I said, hey, let's find the 100th term. That means if I shove the 100 in for n, I would have 1 times 100, which is 100, take away 5, and I would get 95. So in my pattern box, if I continued it out, what I would see is on the top the number 100th, meaning the 100th term, and that 100th term would have the number 95 down below, because the 100th term would be 95. And what you see every single time is when you follow these patterns, for example, in the second box, I notice that every single time here I'm jumping by 4. That's my pattern that I found, jump by 4. So this jump by 4 thing, you will find is the number in front of the n on the bottom of the pattern box. But if I try to use that pattern again, and I try to shove in, like for example, the number 4 in for the n, because I want the 4th number in my pattern, 4 times 4 would have been 16, but I see the number 13 under it in pink. So that means I have to adjust by 3, and that's why you see the minus 3 after the 4n. Now, let's go look at this next slide and see what's going on. Let's see if we can generate our own rules. So remember, this stuff is saying, so as we look at the pattern in this one, what I'll notice is going from 10 to 12 is an addition of 2, going from 12 to 14 is an addition of 2, going from 14 to 16 is an addition of 2, which means that I'm going to have 2n. Why? Because I noticed that my pattern was to jump by 2, so that's where this 2 is coming from. Then, I noticed that, for example, if I wanted my second term, and I were to plug that, actually let's go with the third term. If I were to plug the 3 in for the n, I would have 2 times 3, which is 6. Uh-oh, I actually see a 14 down below the 3. So I got a 6, but I end up with 14. Let's see what happens if I plug in the 5. If I take that 5 and I shove it into the n, I get 5 times 2, which is 10, but I saw an 18. I'm 8 off every single time. So to find my pattern, I have to add 8. And now I can go to any number, any term, and find its value in the box. So 2 times 1 is 2, plus 8, 10. 2 times 2 is 4, plus 8, 12 down below. 2 times 3 we already did. 2 times 4 is 8, plus 8 more is 16. And I've adjusted for what's going on in the box. And so you see your final pattern that you need is going to be 2n plus 8. And that's down below here in the yellow highlight. We can do that again as another example in this second chart down below. So I look at the same kind of thing. I look, oh look, from 10 to 7, that's a decrease of 3. From 4 to 1, that's a decrease of 3. Everywhere I am decreasing by 3. That means I'm going to have negative 3n. But as I check to see what's going on, if I take, for example, the number 4 out of my term, and I say I want to talk about the 4th term, and I shove that 4 in for the end, which is the term number, negative 3 times 4 gives me negative 12. But I see a 1. Whoops, I'm off. So then I check another one maybe, and I put in the 6 there for the end. Negative 3 times 6 is negative 18. But I see negative 5. I notice that every single time I'm off by 13. So I add 13 to my pattern to adjust for what's actually going on. So now my rule is negative 3n plus 13. And this negative 3n plus 13 will generate any value in the box. So I could say something like, hey, I wonder what the 10th term will be. So I could go, hey, negative 3 times, oh, the 10th term plus 13 more, or in other words, negative 30 plus 13, which would yield negative 17. Or in other words, the 10th term should be negative 17. So once you find these rules, it's very convenient to be able to find any term in the pattern that you want. Remember, the top numbers are which term number it is, and the bottom numbers are the value of that term. Looking at this next example in finding the nth term, we see a pictorial example. So in this pictorial example, is you always have to find the rule so that you can find your answers. So let's say that maybe we're trying to say we're putting 200 points on a line, and how many non-overlapping rays and segments are created. Look at the picture down below. If I'm looking at, for example, the very first thing that I see in my table, meaning that there's 1 point. Let me draw a picture that exemplifies this. So in this red line that I'm going to draw first, here's my red line. If I put 1 point on that line, what I notice is the 1 in the chart corresponds to the points on the line. Secondly, I notice that there are 2 rays, one to the left and one to the right. And oh, look, there are no overlapping segments. So that's where the 0 comes in. Okay, well, let's move on then. Let's say that we're going to talk about the second piece of the chart. In this piece, if I draw a second example, in blue here maybe, and I put 2 dots on it, 1 point, 2 points. Now from the chart I notice that there are 2 points, that's the very first number in the blue, and then there are 2 non-overlapping rays, one to the left, one to the right, and then in the very middle of the 2 rays there's 1 segment, and that's where the 1's coming from in the chart. I could do this again, of course, so I could say, hey, what if I want to talk about if I put 3 points on the line? So I draw a line and I put 3 points on it. 1, 2, 3. That's where the 3 is coming from in the purple highlight. I notice that on the ends, left and right, there are rays, so there's still 2 rays. But in the middle, there are 2 segments, and that's where the second 2 in the purple highlight is coming from. And I start to notice this pattern. In fact, I notice that the fourth part of my chart is referring to the original picture that I had up there with 4 dots on it. And I see that if there are 4 dots or points, that there's still 2 rays. These rays that I keep referring to are the rays that are on the ends. This is one of the rays, of course, and here's the other ray on the end. And so that's where the number 2 is coming from every single time in the middle. And I see that there are 3 non-overlapping segments in the middle. And I start to see this pattern. For example, I notice that no matter what I do, every single time, there's always going to be 2 rays. I notice that no matter what I do, the number of segments always is 1 less than the number of rays, the number of points that I have. So notice that the 199 here is always 1 less than the number of points I have. So this is a pattern that I'm generating from this. And so in the end, what you deduce from all this information is this stuff right here in the pink circle. That for n number of points, there will always be 2 rays on the ends, and always 1 less than the n minus 1 for the number of non-overlapping segments. Again, the whole point of this is to use deductive reasoning so that you can develop the pattern and see what's going on and create a rule. You want to be able to create rules for these. So in the pink circle are the rules for what's going on in our example.